Yeah, good day to you all viewers. You all are welcome to physics class with Tutor Josh. Please, if you haven't subscribed to our YouTube channel and you've not followed our Facebook page, please consider doing that. Thank you. So in today's class we are discussing dimensions of physical quantity. As we all know, in physics, we have the fundamental quantity and we have the derived quantity. Where we have the fundamental quantity as the basic quantity that gives the standard unit of measurement. And we have the derived quantity as the quantity obtained from fundamental quantity in form of combinations. And these fundamental quantities, we have examples of fundamental quantities are fundamental quantity. Let's first talk about this. Fundamental quantities. These quantities are quantities in which through them we have the standard unit of measurement. And examples are, we have the major fundamental quantities, the three major we have the mass, we have length, and we have time. And the dimension of each of these, dimension of mass is given as m, dimension of length is given as l, and dimension of time is given as t. So the derived quantities, they can obtain their dimension too through combination of these three major fundamental quantities. Now let's take, for example, we are considering the dimension of speed. To get the dimension of speed, it's very simple. What we need to do is we must know the formula for calculating speed. And what is speed? Speed is rate of change in distance with time. Rate of change of distance with time. That is, speed is given as distance over time. So if speed is given as distance over time, so therefore speed is equals to the dimension of distance. Distance is given as length. Dimension of distance is regarded as length. So here we have L over dimension of time, which is t. So and this can be written as LT raised to power minus 1. So the dimension of speed is LT raised to power minus 1. That is length over time. Now what of velocity? Velocity. What is the formula for calculating velocity? Velocity is just the rate of change of displacement with time. That is, it is given as displacement over time. And displacement as well is also regarded, its dimension is regarded as length. It's taken as length. So this gives us velocity equals L over t. And that gives us LT minus 1. So the dimension of speed and velocity is the same. Now let's consider dimension of linear acceleration. Linear acceleration. The formula for calculating linear acceleration is given as rate of change of velocity with time. That is, linear acceleration is given as velocity over time. And the dimension of velocity, we've gotten it to be LT raised to power minus 1. So this is same as writing LT raised to power minus 1 over t, because the dimension of time is t and dimension of velocity is LT raised to power minus 1. Then this can be written as LT raised to power minus 1, t raised to power minus 1. And from indices, we can combine this because they have in the same base. And this will give us LT raised to power minus 1 minus 1. And that gives us LT raised to power minus 2. So the dimension of linear acceleration is given as LT raised to power minus 2. Now let's consider force. Force. What is the formula for calculating this force? Force is given as the product of mass and acceleration. Force is given as the product of mass and acceleration. Now look at this. It means force is given as mass times acceleration. And the dimension of mass is given as m. So this can be given as m times dimension of acceleration. We've gotten it to be LT raised to power minus 2. So and this can be taken together. We have m LT raised to power minus 2. So the dimension of force is also given as m LT raised to power minus 2. So you can see this, it goes on and on and on like that. Once we can get the formulas to calculate them, then we can make use of how they can be combined using the major three fundamental quantities. Now let's consider one more. Let's consider power. Power. What is the formula for calculating power? Power is given as rate of work done with time. So it means power is given as work done over time. So then it means we first need to look for the what? For the dimension of work done. We first need to look for the dimension of work done. And what's the dimension of work done? Work done is given as the product of force and distance. So work done is force times distance. So if work done is given as force times distance, then what is the dimension of force? We've gotten it to be ml raised to power minus 2. So this can be written as ml raised to power minus 2 times dimension of distance is regarded as L. So this will be L. Then on taking this L and L together, then this gives us ml squared T raised to power minus 2. So the dimension of work done is given as ml squared T raised to power minus 2. Now, what is now the dimension of power? The dimension of power is given as work done, which is ml squared T raised to power minus 2 over the dimension of time, which is T. Then this can be written as ml squared T raised to power minus 2 T raised to power minus 1. Then on combining this, minus 2 and minus 1 because they have the same base, then this gives us ml squared T raised to power minus 3. So the dimension of power is given as ml squared T raised to power minus 3. You can see how this is very simple. Once you can get the formula of the quantity, then we can derive it dimension. Do not forget, dimension is just how these are related to fundamental quantity. Thank you. Please do not forget to follow our Facebook page and also subscribe to our YouTube channel.